Good day, everyone. Today, I am going to discuss to you the interquartile range and the 1090 percentile range, which is also the part of measures of variability. Okay, let's start with the interquartile range. As the dispersion of the frequency distribution is increased, the distance between the quartile is enlarged. Since an increased dispersion will be indicated by a greater distance between the quartiles, this distance may be used as the basis for a measure of dispersion. So this is the formula for interquartile range. So that means we are going to solve for the quartile 3 and quartile 1. Then subtract quartile 1 from quartile 3. Okay. Let us have an example. So the following are the heights of 50 students in PUP expressed in inches. So the first column, we have the heights of the students, 60 to 64. So that is the class interval in between. So that is in inches. So we also have the frequency. So the total of our frequency is 50 since we have 50 students. And the cumulative frequency. So the first column here, the 6, we just copied the frequency. Then 6 plus 13, then we have 19. 19 plus 15, we have 34. 34 plus 12, we have 46. And 46 plus 4, we have 50. Okay, so the first thing we need to solve is the quartile 3. So the formula for the quartile 3 is this. So quartile 3 is equal to the lower class boundary plus the quantity 3n over 4 minus less than cumulative frequency over frequency times interval. Okay, so before we solve the quartile 3, we need to solve the 3n over 4. Okay, so the value of our n is 50. So it came from here, 50. Okay, so let us substitute n, 50 to n. Okay, so 3n over 4 is equal to 3 times 50 over 4. Then 3 times 50 is equal to 150 over 4. Then 150 divided by 4 is 37.5. Okay, so after we get 37.5, we need to look up 37.5 in this column, less than cumulative frequency. So as you can see, there is no 37.5. So all we need to choose is the next number higher than 37.5 is 46. Therefore, our quartile 3 class is this. Okay, so this is our Q3 class. That means we will base our values from this class. Okay, so let us get the lower class boundary. So our lower class boundary is 74.5. It came from 75 minus 0.5. So we have 74.5. Okay. Next is less than cumulative frequency. The next number less than 46. Okay, so our less than cumulative frequency is 34. Next is frequency. So our frequency is 12. And our interval is 5. So from our interval here, we have 5. Okay. So all of these values, we are going to substitute these values to the formula. So let us now solve. So this is the formula and these are the values. So let us now substitute the values to the formula. So lower class boundary will become 74.5 and 3n over 4 will become 37.5. So it came from here. And less than cumulative frequency will become 34. And our frequency will become 12. And interval is 5. So using the PEMDAS, of course, we are going to solve first the values inside the parentheses or the bracket. So 37.5 minus 34, we have 3.5. So 3.5 divided by 12, just use your calculator. We have 7 over 24. Then multiply by 5, we have 35 over 24. Then 74.5 plus 35 over 24, the answer is 75.96. So this is our Q3. Now let us proceed to the quartile 1. So the same procedure as quartile 3. So the formula for quartile 1 is Q1 is equal to lower class boundary plus the quantity n over 4 minus less than cumulative frequency over the frequency times the interval. So just like quartile 3, we have to solve first n over 4. So our n is also 50, which came from our total frequency. Okay, so n over 4, substitute 50 to n. So 50 over 4 is equal to 12.5. Now we are going to find 12.5 to the column of less than cumulative frequency. So since there is no 12.5, therefore we have to choose 19. So the next number higher than 12.5 is 19. Therefore, this row is our Q1 plus. So we are going to base our values to this row. Okay, let us get the lower class boundary. So our lower class boundary is 64.5. So it came from 65. So we have 65 minus 0.5. So we have 64.5. Okay, next is our less than cumulative frequency. So the next number less than 19 is 6. So that is our less than cumulative frequency. Then frequency is 13. So it came from here. Then our interval is of course 5. So it is also based on the class interval here. Okay. So these values, we are going to use that to solve the quartile 1. So this is the formula for quartile 1. And these are the values. So we are going to substitute the values to the formula. So lower class boundary will become 64.5. N over 4 will become 12.5. Less than cumulative frequency will become 6. And the frequency will become 13. And our I, or the interval, will become 5. Okay, using the PEMDAS, we're going to solve first the values inside the parenthesis or the bracket. So 12.5 minus 6, we have 6.5. So 6.5 divided by 13 is 1 half, or you can use 0.5. Then 1 half times 5, we have 5 over 2. Then you can use your calculator to solve it easily. So 64.5 plus 5 over 2, we have 67. Therefore, the value of our quartile 1 is 67. Okay, so let us now solve the interquartile range. So the formula is Q3 minus Q1. So the value of our Q3 is 75.96 and our Q1 is 67. Now we are just going to subtract Q1 from Q3. So that means QR is equal to 75.96 minus 67. Then our answer is 8.96. So this is now our interquartile range. Okay, let us now proceed to 1090 percentile range. In similar manner as the dispersion is increased, the distance between the various percentiles will be increased. The distance between the two percentiles may thus be used as a measure of dispersion. So for the formula of 1090 percentile, we have P90 minus P10. So that means we are going to solve for the P90 and P10. Then subtract the value of P10 from the value of P90. Okay, let us have an example. The length of time for a cashier at JR Food Plaza was recorded for 80 customers. Okay, so this is the time, in seconds, or this is also our class interval. And the frequency, the total frequency is 80. Then our less than cumulative frequency, okay? Okay, so the formula for the P10, let us solve first the P10, then later is the P90. Okay, the formula for the P10 is equal to lower class boundary plus the quantity 10n over 100 minus less than cumulative frequency over the frequency times I. Okay, the same procedure as quartile. We're going to solve first the 10n over 100. So our n is 80. So it came from here. So we're going to substitute 80 to n. So that means 10 times 80. It will become 800. Then copy 100. So 800 divided by 100, we have 8. So we're going to find 8 from this column, which is the less than cumulative frequency. So as you can see, there is no number 8. So we're going to choose the number higher than 8. Well, the next number higher than 8, which is 10. Therefore, this row is our percentile class, or P10 class. So we will base our values from this row. Okay, so let us get the lower class boundary. Okay, we have 39.5, so it came from here. 40 minus 0.5, so it will become 39.5. Next is less than cumulative frequency, which is 5. So the next number less than 10, which is 5. Then a frequency, our frequency is also 5. Then our interval is 10. Okay, so these values, we are going to use this to solve the P10. So this is the formula for P10. So P10, then these are the values. Now we're going to substitute the values to the formula. So as you can see, LB, or the lower class boundary, will become 39.5. So it came from here. Then 10n over 100, we have solved it a while ago. So the answer is 8. So that's why it is replaced by 8. Minus less than cumulative frequency. So we have 5. And our frequency, which is also 5. And our interval, which is 10. Now, let us solve first the values inside the parentheses or the bracket. So, 8 minus 5 is 3. So, we have 3 over 5. Then, we can now multiply 10. So, 3/5 times 10 is 6. Then, we can now add 39.5 plus 6 is 45.5. So, this is the value of our P10. Okay. So, let us now solve the P90. Okay, the same procedure as P10. We are going to solve first the 90 n over 100. So our n is 80. So substitute. So 90 times 80, we have 7,200. Then divided by 100. So our answer is 72. Now we are going to find 72 to this column. It's less than cumulative frequency. So there is no 72. So we're going to choose the next number higher than 72, which is 75. Therefore, our P90 class is this column. Okay, so we will base our values from this row. Okay, let us now get the lower class boundary. So we have 89.5. So it came from 90. So 90 minus 0.5, we have 89.5. Okay, next is less than cumulative frequency, which is 65. So we will get this one. The next is the frequency. So this is our frequency. And the class interval, which is 10. So that is according to our class interval. Okay, so these values, we will use that into our formula. So this is the formula for P90, And these are the values that we need to substitute to the formula. Okay, so as you can see, lower class boundary will become 89.5. So it came from here. Then 90n over 100 will become 72. Then less than cumulative frequency will become 65. And the frequency is 10. And our interval is also 10. Okay, let us solve the values inside the bracket. 72 minus 65, we have 7. So 7 over 10 multiplied by 10, we have 7. So 89.5 plus 7, we have 96.5. So let us now solve the 1090 percentile using the formula P90 minus P10. So the value of our P10 is 45.5 and the value of our P90 is 96.5. So substitute or just subtract P10 from P90. So 96.5 minus 45.5, the answer is 51. So our 1090 percentile range is 51. Thank you for listening.